Hey everyone, welcome to another episode of Bug Bounty Redacted. Today we're going to be going through the ability to write to an S3 bucket through put requests, and also the insecure implementation of JSON Web Tokens. So the first thing I want to talk about is S3 bucket misconfigurations. The different types of misconfigurations include the ability to get ACLs, set ACLs, list the bucket, write to the bucket, or take over a bucket. These are all of the things you should be looking for when you test S3 buckets. If you can write to an S3 bucket, you should see if there's any files within the bucket that are being included in the websites that are owned by the company you're hacking on. This could lead to an easy persistent XSS vulnerability if you can override JS files within the bucket that are being referenced on a web page. I suggest that you use the AWS CLI to test for S3 bucket related issues, or when you want to try and override a file, try and send a put request to see if anonymous writes are enabled. Generally, my methodology when it comes to testing S3 buckets is using the AWS S3 CLI and being an authenticated user on AWS. There is a distinction to make on AWS S3 where authenticated users have more privileges sometimes depending on the policies. So you should be authenticated to your AWS account when you use the AWS CLI to test S3 bucket issues. This will lead to you finding more S3 bucket issues because of policies on S3 buckets that allow all authenticated users to do certain actions. So discovering vulnerable buckets, as always, enumeration is key here, and you should spend the time to thoroughly enumerate every DNS record in an attack surface for references to S3 buckets or CDNs like CloudFront. Sometimes other CDNs will also be pointing to S3 buckets, and sometimes it's not really clear what the S3 bucket name is. In order for you to actually do anything to the S3 bucket, you usually need access to the S3 bucket name or need to know what to call in the CLI to be able to access that bucket. There is a tool by Franz Rosen called the S3 bucket decloaker script, and it will identify the name of the S3 bucket for you if it's possible. There are various tricks to decloak a bucket, and I know that there is a bunch of tricks that are somewhat private in our community and not shared. So these are things that you can do to discover these S3 buckets, the names of these S3 buckets that you might need to do a little bit of probing for to understand how to get there. But there is this decloaker script which is public, but there are also private techniques out there that allow you to decloak S3 bucket names even when they're behind CDNs like CloudFront. I also suggest that you spider and crawl the web applications on an attack surface to identify all of the references to S3 buckets for the organization. This is really important because there might not be any DNS records that are pointing to these S3 buckets, but these S3 buckets could be potentially referenced in the JavaScript or in the HTML just generally when you crawl a website or spider a website. So what did my report look like when I reported a S3 bucket misconfiguration? So I started it off by saying, look, I've got the ability to write arbitrary scripts to these two buckets through the misconfiguration. I stated that I had found a critical vulnerability affecting this S3 bucket, and it allowed me to read, write, and move arbitrary files in the public directory of the bucket. Reading the bucket list of files wasn't possible. I noticed that this bucket was used for a large number of resources and assets for multiple subdomains and applications. The two main applications I found I listed in the report, and I said that there were multiple pictures and other things that were writable in the public directory for this bucket that were referenced on web applications on their attack surface. I was able to show them that there were no access controls in place for both writing and replacing files in this bucket. And I did this by demonstrating a HTTP put request, which was overriding a JPEG file with actually an SVG file. And due to the way that S3 works, depending on the content type, it will reflect that file as an SVG even though the extension is .jpeg. So this was just proof that I could overwrite files in this bucket and just something to start off with in this report. I then showed them that the response for this put request was a 200 OK, indicating that the put was successful. I then showed them that, hey, it's possible to take over these two subdomains because there's actually a JavaScript file that's being referenced from this S3 bucket on these URLs. And by overriding this JavaScript file, what we can do is we can inject our own arbitrary JavaScript that will be ran when you visit these two URLs. As a proof of concept, I added a simple console.log, which wasn't harmful in any way and just proved that I was able to write to these JavaScript files. I also included some screenshots which demonstrated that I was able to write to the console logs as some proof as well. And lastly, I tried to explain what the impact of this vulnerability is. I explained that you could do things like deface both of these domains. You could serve malware and exploit kits. You could do phishing attacks. You could do tracking, keylogging, or infecting local storage data for all the visitors. You could modify leaderboards and other data on these domains through JavaScript. You could also steal administration sessions by injecting beef hooks into every visitor and determining the admin user. So I told them that I thought it was a pretty serious issue because it affected these two major domains that this company was using. And ultimately, they paid $7.5 grand for this finding. So I think that this was a pretty critical finding for them, and they did appreciate it quite a bit. Next thing I want to move on to is JWTs. So there's common flaws in JSON Web Tokens, and I highly recommend that you check out this Pentester Lab exercise on JWTs. I learned a lot from this Pentester Labs exercise, and it will help you understand what JWTs are and how to exploit misconfigurations in JWT implementations. After completing this course and exercise, you'll be able to understand the report I'm about to present. JWTs are easily identifiable, and testing them is a must every time you come across them. There's a few burp plugins like JSON Web Token Attacker and JSON Web Tokens that can be really useful when attacking JWT implementations. So the report for this one looks something like this. I said, hey, there's a insecure implementation of JSON Web Tokens at this URL. I've found that this URL is responsible for dispensing these skin codes when you go through Facebook and associate your account. So here's an example of an innocent request to obtain a skin code. You can see that this request is being sent to /getCoupon, and it's including a Facebook ID. There's also a cookie that it's including which contains a JWT. The cookie looks something like this, and you can see that the cookie, once decoded, has this algorithm of HMAC SHA-256. I was able to work out that by simply changing that algorithm to none, we could change the user ID to an arbitrary value and it's accepted by the web application. For example, I changed the user ID to 1 and then re-encoded the payload to get the following base64 JWT. And I was then able to use that and increment my Facebook ID to request a number of free skin codes, as many as I wanted, to be honest, by simply incrementing the Facebook ID parameter. So ultimately, on the back end, this wasn't doing validation that the JWT was actually signed correctly. It was accepting a none algorithm, which let you essentially sign your own JWT and have arbitrary user IDs in the JWT. Thanks for watching this episode of Bug Bounty Redacted. I really do appreciate all of your support, and I look forward to making more episodes for everyone.